Hello, this is Dr. Michael Hassan, the Engineering Doctor, and this is lecture number 9, Karnaugh Maps, for Chapter 3, Combinational Networks, for the course titled Digital Logic Design for Digital Systems or Digital Electronics. This is a disclaimer for you to read. There are many references in digital logic designs. I name few references here, but there are many more on internet or at your library. Chapter contents. In this chapter, we will introduce combinational networks, analysis and design. We'll talk about Karnaugh Maps today, which is 2-variable maps, 3-variable maps, 4-variable map, 5-variable map, and 6-variable map. Then we'll talk about incompletely specified functions, complement of a function, canonical and standard forms from K-map, two-level implementations, plotting functions on the map, design of multiple output combinational networks, variable-dependent functions, and map-entered variables, propagation delay and timing hazards, Quinn-McCluskey method for minimization, prime implicance chart, incompletely specified functions, Matrix method, and we'll look at VHDL design too. What's a combinational network? A combinational network is a logic circuit that consists of logic gates only. So the circuit may consist of inverters, buffers, AND gates, and NAND gates, etc., etc. No feedback loops in combinational networks, and there is no memory element such as latches and flip-flops in combinational networks. Because if there are latches and flip-flops, the network will become non-combinational and it will become a sequential network. Karnaugh maps. Karnaugh maps are used to minimize Boolean functions, also known logic functions or switching functions, to minimal functions. A minimal function is a switching function with a minimum number of terms and minimum number of literals. So we need a minimum number of switching variables and minimum number of terms or product terms. A Karnaugh map is a modified form of a truth table where the arrangement of combination is cyclic, that is in a gray code format. The arrangement allows the minimization of Boolean function based on the laws of complementarity. Hence, for instance, if we say AX or AX prime, we factor out A will be X or X prime, which is equals to 1, and A and 1 is A, where A denotes a product of literals and X denotes a single literal. So based on this principle, K-map can be used to minimize any Boolean function. Minimization procedure. Each n-variable map consists of 2 to the power n cells. Also, we will see them as squares, representing all possible combinations of these variables. Each cell of an n-variable map has n logically adjacent cells, with each pair of adjacent cells differing in exactly one variable. For example, A prime B prime and A prime B are logically adjacent minterms since they differ in variable B. See, we have B and B prime. So those are adjacent, logically adjacent cells. Hence, each cell or minterm on a map of 2 variables has 2 cells that are logically adjacent. And each cell on a map with 3 variables has 3 adjacent cells, and so on. If we combine cells in powers of 2, it means we can combine 2 cells. Well, we can combine no cells, it means we will combine 1 cell only, 2, we can combine 4, we can combine 8 and 16 and so forth. That is 2 cells, 4 cells, 8 cells, and 2 to the power n cells. When combining 2 cells, we eliminate 1 variable, while when we combine 4 cells, we'll eliminate 2 variables. In general, when we're combining 2 to the power n cells, we eliminate n variables. Note that two cells can only be combined vertically or horizontally, that we cannot combine two cells diagonally, since diagonal cells are not logically adjacent. We can combine only logically adjacent cells. So when we combine, we put a square around the cells, or rectangle around the cells, whether it is horizontal or vertical rectangle. Number 3, we group as many cells together as possible. We start with the larger group. The larger the group is, the fewer the number of literals in the resulting product terms or sum terms. Note that one cell can be used in more than one group as much as needed. Based on Boolean algebra, x or x is equals to x. So we can use a cell in more than one group. All cells must be covered, that is, each cell with logic 1 for the sum of product minimization, or with logic 0 for the product of some minimizations, must be included in at least one group for complete minimization. We start combining those ones that cannot be combined with other one cells, and continue with groups of two one cells, and so on. 4. Make as few groups as possible to cover all cells. The fewer the groups are, the fewer the number of product terms or sum terms in the minimize function. A function f is expressed as a sum of a product or product of some where each product term or sum terms corresponds to the group necessary to cover its one cells or zero cells. Now, two-variable K-map. Since we have two variables, a and b, we will have 4 cells because 2 to the power 2 is equals to 4. Now, a is the most significant bit, so in the truth table we have ab, we'll have 0, 1, and 0, 1 for b. Okay, and those are the location of the midterm in each cell. This will be M0, which is 0, 0, and M1, which is 0, 0, A0, and B is 1. And this is M2, and this is M3. So M2, because I will have 0, and M3 will have A is 1, and B is equal to 1, which is only to M3. So those are the location of the midterm. We call this is the key map. Okay, but we can put the number of midterm at the corner here, 0, 1, 2, 3. Those midterms, again, they are A prime, B prime, A prime, B, AB prime, and AB. Some people prefer to mark the K-map with the positive and negative literals for the switching variables. So this will be A here because A is 1, and this is B because B is 1, so this will be B bar, and this will be A bar. So A bar, B bar will be A bar, B bar. Okay. Or some people just would like to read the bit and figure out that this is really A. So when you see 1, this is indication A because we are at the x's, we have the A variable. So those represent the A variable, A0 here, A equal to 1 here, and B equal to 0 here, and B equals to 1 here. Let's take a simple example. If we have minimized the following function using K-maps, and we have the function is the sum of midterm 1 and midterm 3. Since we know the location of midterm, so this will be 1 here, this is midterm 1, this is 0, 1, 2, and 3, and this is 3 will be 1. So this will be A prime B, which is midterm 1, and this is AB, which is midterm 3. Now here we can establish one group, which is a group of 2. We can combine those two cells because I have 2 1s, so I can combine them here. And we say horizontally the 0 will cancel with the 1 for A, so I have only the vertically I have B is 1, so the answer will be F is equals to B. So simply the one group generated F is equals to B. So here we will simplify AB or A prime B to B. And this is very true because in Boolean algebra, if we factor out b, you will get b multiplied between parentheses a or a prime, which is Boolean algebra, it is 1, which is b times 1, which is equal to b. So f is b. By using K-map, we figured out that f is equals to b. Now minimize the following functions using K-maps. We have g equals to m0 plus m3, h is m1, m2 plus m3, and I will be m0, m1, m2 plus m3. So let's look at the answers here. For g, we cannot group. We have a prime, b prime, or ab, because we can group this one circle on its own, and this one with one circle on its own. So this is a group of one cell, and this is a group of one cell. We cannot group those together because they are not logically adjacent. So we cannot group them. We cannot group diagonally at all. We can group only horizontally or vertically. So this is really will have no minimization, and G will be A prime, B prime, AB. There is no minimization. Now we could have a 0. This is the second function at. We will map it to get 0, 1, 1, 1. So here we can group. This is a group of ones on the vertical side, and we have another group of two ones on the horizontal side. So this group will give me 0 will cancel with the 1 for B, and I will have A because A is 1. And I will say 0 will cancel with the 1 for this group, horizontal group, 0 will cancel with A, and I will have B. So the answer here will be A or B. A or B. A came from this group, from the vertical group, and B came from the horizontal group. I is the sum of the midterms M0, M1, M2, and M3, so we have 4 ones, and we have one big group. We can group them all, one group, okay, and 0 will cancel with the 1 on the horizontal side, 0 will cancel with the 1 on the vertical side, so I will have 1 when they cancel. I will have 1 and 1, 1 and 1 is 1, so the output will be 1. The answer for the function I will be equals to 1. Let's look at 3-variable maps. In 3-variable K-maps, it has 8 cells, 1 for each midterm, can be arranged horizontally or vertically. This figure will show you the horizontal arrangement for K-map. We have A, B, the most significant bits, and C. We arrange the bits in cyclic form. We have 0, 0, 0, 1, then we say 1, 1, then 1, 0. Okay, so the 1, 1 before the 1, 0. Then the C will be 0, 1. Now the location of the midterm, we have M0, M1, M2, M3. Then we jump one column, M4, M5. Then we go back M6 and M7. Well, we can put the number here for the value of the midterm. We get 0, 1, 2, 3, 4, 5. We jump one column, 6 and 7. And those are the values of the midterms actually in every cell. Again, we can label where A is in the map. This is because A is 1 here and 1 here, so both two cells will represent A. This cell represents C, and this cell will represent B, because again, we have both B is equals to 1 here and B equals to 1, so those two cells will represent B. Those are really the marking for A, B, and C on the map. They are very optional, and some people use them and some people do not. I prefer not to use them at all. Now, the other representation, which is the vertical representation of the map, where we have the most significant bit here, then I have BC. So I have 0, 1, then the BC will be 0, 0, 0, 1, 1, 1, and 1, 0. And the midterms will be M0, M1, then we jump one row, M2, M3, M4, M5, we jump one row, M6, and M7. And those are the location values of the midterm. 0, 1, 2, 3, 4, 5, 6, and 7. And those are the values of the midterms again in every cell. Let's take an example. We have the midterm 4, 5, 6, and 7. 4, 5. So this is 4, this is 5, and this is 6. We have ones. So we put ones. So this is the two ones here can be grouped with one pair. Okay, this pair can be grouped, and I will have one will be left, so I group it as a pair. I cannot take it as unknown because this will be not the best minimization. When I group those two, I can take this one on its own. Well, this is not a good minimization, but I can group it with this. As we said, we can group the one, we can reuse the one from one group with another group. So with these two groups, this group, the vertical group, will give me A, B prime, and because the C will cancel out, C will cancel out with 1. And this group, I will have the 1 will cancel with the 0 for the B. So I have A and C prime. So I will have A, C prime with for the horizontal pair. Another problem, we have 0, 1, and 4 and 5 midterms in F2. Okay, so F2 will be the sum of midterm 0, 1, 4, and 5. We fill out the map with ones. Then I have 1, 1, and 1, 1. We can here rotate the map to look like a cylinder. We can rotate it vertically and horizontally. When we rotate it horizontally, it will look like a cylinder. So those two cells can combine with those cells because they are logically adjacent. Because they are different with A. I have here A0 and A here is 1. And this group, what will give me? The 0 will cancel with the 1 with the C. The C is missing here. And the 1 will cancel with 0 for the A, so I have only B prime. Why B prime? Because 0 here and 0 here. So F2 will be B prime, the complement of B, and this will be my answer. As a circuit, just I will take B to an inverter, and I will get an F, or the output will be F. I would like to minimize the Boolean function F3, which is the sum of M0, 2, midterm 0, 2, 4, and 6. 0, 1, 2, 3, 4, 5, 6, and 7. So 0, 2, 4, and 6 will be all ones. And this is a group of 4. I have 0, 0, 0, 1, 1, 1, 1, 0. All of them will be cancelled out. So I have the only thing I can see on the C part is C prime. So F3 will be C prime. Now let's look at the fourth variable K-maps. The fourth variable K-maps, I have A, B, C, D. We'll have 16 cells, each cell for one midterm. So I have the location, and very important to when you draw the map 0, 0, 0, 1, 1, 1, 1, 0. Again, we'll have the 1, 1 before the 1, 0 because it has to be cyclic. One bit change at one time from one cell to the other. I have also here 0, 0, 0, 1, 1, 1, 0. And the location of the midterm as shown will be 0, 1, 2, we jump a row, 2, 3, 4, 5, 6, and 7. Then we jump a column, we'll have 8, 9, 10, 11. Then we go back to this column, 12, 13, 14, 15. So this is the midterm A, B, C, D, and those are filled out here. We can fill out the value of the midterm at the corner. It's a good practice, so we don't forget the location of the midterm. 0, 1, 2, 3, 4, 5, 6, 7. Then we jump a column. Then 8, 9, we jump a row. 8, 9, 10, 11. 12, 13, we jump a row. 14, 15. So this will be 15. Example, we would like to minimize the following Boolean function. Okay, those functions, function 1 is the sum of midterms 1, 5, 9, 12, 13, 14, 15. Function 2, the sum of midterms 0, 2, 8, 10. F3, the sum of midterms 1, 2, 6, 7, 9, 13, 15. F4, the sum of midterms 0, 2, 4, 6, 8, 10, 11, 12, 13, 14, 15. F5 is the sum of midterms 1, 10, 11, 12, 13, 14, 15. And F6, the sum of midterms 0, 1, 2, 3, 8, 9, 11, 12, 13, 14, and 15. And for F1, we generate this map. We fill out this map with a midterm. So we get 1, 1, 1, 1. This is very clear. It's a group of 4. We can group them. And horizontally, the CDs, all of them will be cancelled out because I have 0, 0, I have 2 zeros, and 2 ones will cancel out for the C, 2 zeros and 2 ones will cancel out for the D. So the only thing I see, AB is 1, 1. So this will be AB. So this group of 4 will give me AB. And this group of 4, everything will cancel out horizontally, and I will get C prime D. So the answer will be AB or C prime D. Let's look at the next example. F2 will give me 1, 1, 1, 1. Here, if we can imagine that this corner could be added to this corner, and this corner can be wrapped in this corner, so the shape will look like a flower. Okay, we'll add up. So those corners could be combined because all of them logically adjacent. Okay, and this will yield the following. We have horizontally the one for the A will cancel out, so I will have B prime, and vertically this 0 will cancel out with 1 for the C, so and I will have D prime because D prime is 0 here, 0 here, D, so this is D prime. So I will have B prime, D prime will be the final answer. This example will give me actually 1, 1, 1, 1, so this is a group of 2, this is a group of 2, this is a group of 2, and I have this one. To cover this one, I can cover it with this one by rotating the map. So this is also a group of 2, and I can read these groups. So this group of 2, I have the 0 will cancel with the 1, so I will have A, okay, and I have C prime D, A, C prime D. This group will give me, I have the 1 will cancel with the 0 for the A, so I have B, C, D, and B, C, D. This group, I will have, the 1 will cancel with 0 for the B, so I have A prime on the horizontal side, and on the vertical side, I have CD. So I have A prime, I have the B will cancel, so this group I have actually the 1 will cancel the 0 for the B, so I will have A prime and C D prime, A prime C D prime. This group here, A prime C D prime. This group, this and this group, this one, I have the 1 will cancel with the 0 for the A, so I have B prime horizontally, and vertically I will have C prime D. So it is B prime C prime D, and by doing this we'll have the final answer for F3, which represent B prime C prime D, A C prime D, B C D, and A prime C D prime. And this is the minimal solution, and this is the minimized function and for the function F3. The next example, we fill up all those minterms, and those 4 with those 4, we can combine them as a group of 4, but this is not the best answer because those 4 with those 4 can be grouped by rotating the map horizontally, and this will end up as a group of 8. Now, horizontally, all of them will cancel out, and vertically, I will have the 0 will cancel with the 1 for the C, so I have only D prime, D prime. So this group of 8 will generate D prime. This group, which is a group of 4, everything will be cancelled vertically for the CD, so I have horizontally AB. Horizontally AB. This group of 4 will give me AC because 0 will cancel with the 1. For the B, I have only A horizontally, and the 1 will cancel with the 0 for the D, and I have C. So my product term will be AC, So I will have the answer will be AC or AB or D prime, and those will be really, we are pointing out the values of those product term accordingly. F5 also will have a group of 4 here, will give me everything will cancel on the vertical side. On the horizontal side, we'll get AB, and this is pointed by AB. This group of 4, will give me a C, because 0 will cancel with the 1, so I will have A, and the 1 will cancel with the 0 for the D, I will have C, so it will give me a C. This one, unfortunately, cannot combine with any other cell. Okay, cannot combine with this because they are not logically adjacent. Okay, if I had one here, it could be combined with this one, but I don't. So this will be on its own. So I'll put circle around it, and this will be A prime, B prime, C prime, D. How we read it? A prime, B prime, C prime, D. So A prime, B prime vertically, and C prime, D. So this will give me the value of this. This group, which is a group of 1, and this will be the final answer of function 5, A prime, B prime, C prime, D, or AB or AC. F6, we may have 2 answers for A6, okay, and those 2 answers are shown in A and B. This is for A and this is for B. We have a group of 4 here, which give me A prime, B prime. Another group of 4, which give me AB. This group will give me A, C prime, and this group of 4 will give me A, the 0 will cancel the 1 for the C, D, which will group A, D, and this is for A. For this one, we could have actually another arrangement. This is a group of 4. We can cover those 2 with those 2. We can cover those 2 with those 2. Okay, and this is another group of 4. So we will get another 4 terms, A prime, B prime, AB, B prime, C prime, or B prime, D, as a second answer. Both answers are minimal answers and are correct answers. 5 variable maps. 5 variable map, it has 32 cells. Each cell will represent minterm. There are 2 really orientation for this map. This orientation, we can have A, B, C, and D, E, which we will have 0, 0, 0, 0, 0, 1, 0, 1, 1, 0, 1, 0. As you can see here, A all 0. Then we'll repeat 1, 0, 1, 1, 0, 1, 0, 0. And this is for B, B, C. So A here is always 1. So I have 1, 1, 0, 1, 1, 1, 1, 0, 1, 1, 0, 0, 1. It has to be cyclic. Has to be cyclic. 1 bit will change at a time. On the DE, it is 0, 0, 0, 1, 1, 1, 1, 0. Or we can go to the 4 variable map and divide every cell to 2 cells, where A is 1 on the top cell, it is the most significant bit. This is the key here, 1/0, and 0 on this cell. So the midterm location will be 0, 1, 2, 3, 4, 5, 6, 7 on the lower cells, 8, 9, 10, 11, then we jump 12, 13, 14, 15. Then we start with 16 here. So we'll get 16, 17, 18, we jump, 19, 20, 21, 22, 23, we jump, 24, 25, 26, 27, we go back to this column, 28, 29, 30, and 31, which is the last minterm. So this is one way to do it, or we can do it this way. There's a third way. We can ignore the A. We can have 2 4 variable map, 1 for DE BC when A is 0, and 1 for DE BC when A is 1. Then when we find the term, we use Boolean algebra where we can really simplify for the A variable only. So this is another approach which I'm not really listing this approach here. Okay, but it could be used. So we have 2 4 variable K maps, 1 for A0 and 1 for A is equals to 1. If you look at the example, we have the sum of many midterms, and we would like to group them as follows. So after we put all the midterms based on the midterm location, we follow up those. We will have those 2 as a group of 2. The 2 ones here with the 2 ones here, they are adjacent, logically adjacent, will be group of 4. The 2 4 ones here with the those 4 ones could be grouped also because they are adjacent, they are at the same location of the map. This one with this one, by rotating the map vertically, could be grouped. This one with this one. Those 4 also can be grouped with one group. And once we have those groups, we calculate those values. For instance, this one with this one, we have the one will cancel with the 0 with the A. So I have B prime, C prime. The 1 will cancel with the 0 for the A. So I have B prime, C prime, and D prime, E, D prime, E. Now this group of 4, I will have the 1 will cancel with the 0 for the C, so I have A prime, B prime, A prime, B prime, and the 1 will cancel with the 0, so I have D, A prime, B prime, D. So I have A prime, B prime, D. A group of those group of 2, those group of 2. So we have those one. If you look, this one with this one, with this one, with this one is all. This is really a group of 4. So I have. We can simplify this group of 2 because I have another group that I did not see here of 2. So I have the 1 will cancel with the 0 for the A, and the B will cancel with the 0 again. Okay, so I will generate actually A prime, the 1 will cancel with the 0, so A is cancelled, and the 1, the 0, the 1 will cancel with the 0 for A, so A is cancelled. So if A cancelled and A is cancelled, then what we were left with, A cancelled, and so I will have B. So this group will be D prime E, D prime E, C prime, D prime E, C prime, because if you look, this cell 0, 0, 0. So I have C is 0. This cell is 0, 1, 0. C is 0. Still C prime. This cell is 1, 1, 0. C is 0. And this cell is 1, 0, 0. C is 0. So the only thing will be left is C prime. So I will have C prime from the horizontal side. It is quite difficult, as you can see. And then I have D prime E. So I have C prime, D prime, E. So this product term here will represent those 4 ones. This one, this midterm, this midterm, this midterm, and this midterm. Okay? And the same thing with this one, the set of 8 will give me CD, because vertically I will have the E will cancel out, so I will have D. And while we get C because again we will have A and B will be cancelled out, so the only thing will be left, C is 1 here, C is 1 here, and C is 1 here, and C is 1 here. So yeah, I have to be very careful. So I will generate CD for the set of 8. For the set of 8. So, and by this, we will have the answer A prime, B prime, D, or B, C, E, or C prime, D prime, E, or C, D. 6-variable map. The 6-variable map, again, we could have four variable maps, one for AB00, one for AB01, one for AB10, and one for AB11, and we can simplify the answer. Or we can have 2 5-variable maps if we wish, and one for A0 and one for A is 1, which is the most significant bit. Or we can take a 4-variable map, and every cell we divide it to four subcells, which is 4 triangles, as you can see here, where this is the key of the AB values. So the AB values will be 0, 0 here, will be 0, 1, will be 1, 1, and 1, 0. They have to be in cyclic order as well. So this is the midterm values will be 0, 1, 2, 3, 4, 5, we jump 6, 7, we jump 8, 9, 10, 11, then 12, 13, 14, 15, then we'll start all over again here. This will be 16, 17, and we go through all the cycle. Okay, then we come here, 32, after we finish the 31, then we start with 48 right here till we end up with 63, which is the last midterm in a 6-variable function. So by doing this, we will generate actually a very compact form of the 6-variable map, and we can solve any problem. So we have one example, example 8. We would like to minimize the Boolean function f of a, b, c, d, e, f given as sum of midterms. If we arrange all those midterms, and I'll show you what we did here. So this is a group of 8. This group of 8 will cancel AB because all the cells of AB were covered. So AB will be fully covered. I will have the 1 will cancel with the 0 for D, so I have C, and I have EF. So EF will be C, E prime, F prime, because I have 0, 0, so C, E prime, F prime will be P0. So P0 will be C, E prime, F prime. This is actually a set of 4 here. They are all of them at the same location of the cell, which is the lower rectangle. So those could be grouped, which is to generate P1. The CD will cancel out. The EF will be E prime F, E prime F, and the AP will be A prime B prime, A prime B prime, and this will be P1. So P1 will give me A prime B prime E prime F, which is very correct. Those 4 also logically adjacent and give me B2, and those 2 are logically adjacent will give me P3. And if you check it out, you will get P2, BC, EF, and P3 will be A, B, C prime, D prime, E. And by doing this, actually, we finished example 8, and we finished this lecture. I thank you so much. So please subscribe, and hopefully to see you very soon. Sincerely, Dr. Hassan. To subscribe, all you need to do is to click on the logo, which is the blue circle. Okay, thank you so much. Again, thanks a lot. Bye-bye. See you soon.